Hello everybody and welcome to a new video for the Spicy Web. I'm using a whole new setup here with Ecamm Live to record not a live stream, but essentially as if it's a live stream. So I hit record, everything's working, the screen sharing, the audio, the camera, all of it. So hopefully this will make it easier to quickly fire everything up and start a new video in the future. More content to come. But for today, we're going to be talking about the slot change event and how you probably can't really use the slot change event for what you think it should be used for, which is why you need a mutation observer. And I'll break this all down for you. So when you're working on a web component and you want to be able to monitor DOM changes that might happen in your component. Say rows are added or removed from a table that your web component is wrapping. You might think, aha, I'll put the table in a slot, and then I'll use the slot change event to see whenever a row has been added or removed to the table, and then I can do something like update a counter or whatever. Number of rows, say. That doesn't work because the slot change event only fires when something has been added or removed from the actual slot itself. As we can see here, the slot change event doesn't fire if the children of a slotted node change, only if you change, add, or delete the actual nodes themselves. So if you were to remove a table from a slot, and then you were to add a new table to a slot, that would fire a slot change event. But simply adding or removing rows within the same table, that doesn't work. So we're going to bring our old friend, the mutation observer, into bear here to be able to monitor whenever rows are added or removed. So I have a file here, an HTML file, and I'm using BBEdit here because I want to showcase just how completely 100% vanilla this is. This is just a text editor. We're just editing an HTML file. This is all very vanilla. So we have this web component here called slotme. We're using the handy dandy declarative shadow DOM template here simply to set up our shadow DOM, which is just a slot. So we have a slot, name is table. Then in our light DOM, we have a table that slots into the table slot with an initial row, initial item, and then a delete button. And then down here, we have a button to add a row. And then we'll take a look at our JavaScript here. So we have a slotme web component that currently doesn't do anything other than logs that the element is connected, right? That's it. So that's all it's doing. And then down here, we have an event listener for our add row button. See, this is an ID of add row. So for add row, whenever you click it, it's going to create a new table row element, stick in some HTML there, and then append it to the table. So if we go ahead and hop over to our web browser here, make sure it's loaded, we see that the element is connected. And okay, we have an initial item here. That's good. Let's see if we can add rows. Cool, we can add rows. And oh, we can't delete rows. So let's add a little bit more here to our connected callback to handle that. And all my cheat sheet stuff is down here. So we'll just go ahead and grab this event listener and paste it in here. So what we're doing here is whenever the entire web component is clicked, so we're being a little bit liberal here with what the potential click target is here. So anywhere in the web component, if it's clicked, we're going to see if the thing that was clicked reads delete, and then we're going to remove the row. And this is really shorthand. There's a better way to do it. Like you could monitor if it was a button that was clicked and what type of button, and you could fancy this up certainly, but we're just doing something really, really simplistic here. So let's go ahead and try this again, adding rows and deleting rows. But obviously, if we click something else, that doesn't work, but the buttons work. Cool. All right, so we can add rows and we can delete rows, but our code doesn't know if that's happened. The web component has no idea if a row's been added or removed, right? It's not monitoring the DOM in any way. So let's go ahead to the next part of our little experiment. Let's first define a callback. So we're going to get rid of this, paste it in here. There we go. So in our callback, we're going to be handed a mutation list. So whenever the mutation observer fires the callback, we're going to get a mutation list. What is this mutation list? What are we getting here? Well, it's essentially an array of mutation records. As we can see here, a mutation record is a read-only interface that represents an individual DOM mutation observed by a mutation observer. It is the object inside the array passed to the callback of a mutation observer. And it has a number of interesting things here. We can look through added nodes. We can look through changes in attributes if that's what we want to observe. We can look through removed nodes, blah, blah, blah. Essentially, added nodes and removed nodes is all we care about because we want to see what happens to the table when it updates. So let's take a look at the code here. We're going to loop through the mutation list and make sure it's a type of child list because that's all we care about. And then if there are any added nodes, we're going to log those. So row added, it'll just grab the first node because that's really all we care about here. Added row, it's going to log that. And then any removed nodes, it's going to log that the row's been removed. So our callback should be working to show whenever a row's been added or removed, but now we have to set up the observer itself. So let's go ahead and grab this chunk of code, paste it in here. All right, so first we're going to get the actual slot element in our shadow DOM. And then we're actually going to grab the first assigned element. So essentially what we're trying to get is the light DOM table that's been assigned to the slot. We could just, do a query selector on our element itself in the light DOM and grab whatever the first table is there. But here we're being a little smarter and figuring out exactly what's been assigned to the slot. We're going to then create our mutation observer, passing it the callback. And then we're going to say we want to observe the slot there using child list is true and subtree is true. Subtree is true. We need that because we don't want to monitor just the table itself, but we want to monitor anything that happens inside the table, aka rows are being added or removed. So let's see if this works. Refresh this. Add some rows. Aha! Look, our console log is working. I can add rows. Let's see if we can delete rows. Aha! We can delete rows. We can add rows. We can delete rows. Now, this will work with anything, right? So that might not be what we want, because if I go ahead and edit this here and wrap this text here in a strong, yeah, it says row added item 1. That's because it's grabbing the text content of just this new node. So what we really want to do here is we want to filter the nodes by the type of tag it is, right? So let's see, what's a good way to do that? I think what we want to do here is this. Rows equals added nodes dot filter node dot local name is tr, and then we'll see what that looks like, and we'll do the same here for removed nodes, and we'll set that for the log. Okay, let's see if that's a little smarter here. Add a row. Not getting anything. Interesting. Well, let's take off the filter here for a moment. And just see what we're getting. We're getting a node list with a TR in it. So, I wonder why that's not working. Do we need to cast this into an array first? Let's see if that makes a difference. I guess that worked. Right, so if we change this to something else, we get nothing. But if we do that, okay, interesting. So if you try to call filter on this node, what is it called? A node list. If we try to filter on a node list directly, nothing happens. All right, so we have to do a splat. Yeah, that's one annoying thing sometimes about direct DOM APIs is sometimes you get these things that feel like they're arrays but aren't exactly real arrays. Yeah, sort of have to arrayify it before it works. All right, this should be working. Okay, so now we get our rows when we add or delete them. All right, so what we really want to do here is have a counter that's like, you know, number of rows in the table is whatever, and dynamically update that. So let's go ahead and update our DOM template, our shadow DOM template. Number of rows, and then we'll, because I'm allergic to spans, we'll use our own little UI label here and start it with 0. All right, well, I guess we could start with 1, technically, if we're having this initial 1 baked in here. All right, 1 row. So now, what we really want to do here is every time there are rows added or removed, so I'm going to go ahead and duplicate that. You know what? Let's be a little bit smarter here. Let's do that. We'll go ahead and grab added rows and removed rows. And then what we really want to do here is if added rows dot length is 0 or removed rows dot length 0. Yeah, that feels pretty clean. All right. Any change to the rows, whether they've been added or removed, we're now going to get the number of rows by, let's see, probably doing this. Dot query selector all tr length, and then we'll go ahead and update our UI label. The number of rows. Let's see if that works. Ha 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 ha! It is updating, and if we delete, nope, that is not updating. if added rows.length or removed rows.length. Interesting. Oh, I know what's going on. I had to look at this for a few minutes. It's because what we really need to do is this, right? We're not initializing an empty array to begin with. So whenever there's only added nodes or only removed nodes, one of those is going to error out. Oh boy. Okay. This makes sense now. Let's do it. Okay, number of rows is updating. And it's still updating. Yay! Victory. All right, well, that's pretty fun. So what did we learn? We learned that the slot change event isn't all that helpful unless all you need to monitor is truly what's being added or removed from a slot. Like if we are to remove this table and then add a different table using this table slot, then this slot would get the slot change event. But that's often not what people want, I think. I think what people really want is to be able to monitor some kind of change within a tree, children of the slot, as it were. So this is the way to do it. When you connect your element to the DOM, you also want to set up a callback that you can pass to MutationObserver. And then when the observer monitors that subtree, it can let you know whenever some kind of child is added or removed, and you can inspect those changes as we have here by filtering to find only table row elements in this case and get those, and then we can go ahead and update our number of rows. And there you have it. All right, I hope you enjoyed this edition of the Spicy Web. What do we want to call this series? The Spicy Web, something about cooking. Let's see. The Chef's Kiss series of the Spicy Web. Mwah. See you next time.